Hello everyone, welcome back to our channel. We are going to discuss here how to come up with a standard form of quadratic function when we are only given with enough details as to what is the vertex of our parabolic graph. On the previous video, we were able to discuss in coming up with a standard form of quadratic function using the intercepts. We also have graph before in the previous video, but it was very clear on that graph that the intercepts are given to be whole numbers or they are actually indicated with exact value. But for these two graphs here, the intercepts, again, that we are concerned with is the x-intercept, or in other sense, it's the point or a pair of points where the parabolic graph intersects the x-axis. In graph number 1, yes, our graph intersects the x-axis, but we don't know the specific value of these intersections, whether it's just 1/2 or whatever fractions it would have. For number 2, it's very clear that our graph does not intersect with the x-axis and hence it has no x-intercept, and therefore we cannot use the processes that we have in the previous video. But here we have actually the vertex form, and from the name itself we are going to anchor on the given vertex because it's the special point in our parabolic graph where it is definite and given here. Aside from the intercepts, we can also get the standard form of a quadratic function if we are given even by just the vertex. Take note that for number 1, the vertex is here and each of this grid are assumed or presumed to be 1 point. So we could just simply label this later on as to the correct coordinates as well as for number 2. But before we could continue, let us talk about what is the vertex form. The vertex form is another form of a quadratic function expressed in this manner: f of x equal to a times x minus h, the square of that binomial, plus k. So this is the standard form, this is the vertex form of a quadratic function. And with this, we can still get the standard form once we substitute the values of a, h, and k. H is actually the x-coordinate of your vertex, and k is the y-coordinate of your vertex. So once we know what is the coordinate of the vertex, we can just definitely say later on what are the values of x, h, and k and substitute here. Now, for a, I also mentioned in the previous video that whatever functions that we could gather here, it's just one of the possible representative standard form of quadratic function because of the presence of this a here. A is any constant, and if you can still remember, a is the leading coefficient of a quadratic function. The value of a here can differ, just like if you are going to treat that as 1 or greater than 1 or less than 1, and we can also predict the movements of our functions later. Just for the purpose of this, so that we could come up with one example of a standard form of quadratic function, we are going to treat a as equal to 1. Just for this process, because what we would like is to get a standard form, even just by 1 point, the vertex, we could get it. And let's just assume that a equals 1 so that we could have an easier process later. So let's start with number 1. The vertex here is given at this point here, and we have 2 points below. Take note that this is your x-axis, and that's your f of x axis, or also known as your y-axis. In short, the movement from left to right is your x-coordinate, and above, below, or top to bottom is your y coordinate. The vertex here is given as 1 and negative 2. This is our vertex. And we are to substitute this to our vertex form to come up with our vertex form first. And after that vertex form, we are going to come up with our standard form. Let's start from here. Our vertex form is given as f of x is equal to a times the square of the binomial x minus h, and then you have here plus k. Again, h is your x coordinates. This is your h. This is also your k. And since again we treat a equals 1, the first step that we could do is to get the vertex form of the quadratic function, and it's given as f of x equal to, when a is 1, you don't need to write that. You have here x minus the value of your h, which is 1, and you square that binomial, plus the value of k, which is negative 2. Wait, this is not yet your final form, because if you're asking about the vertex form, it should be simplified. I'm talking about this portion here, not the square of the binomial, because if you're going to do that, then you're going to lead to a standard form already. But the question is just to reach until the vertex form first, so that we could differentiate it later on to what is the standard form. So again, the goal here is to just simplify this first. So your final vertex form is, let me change the color. So the vertex form is this blue. Okay. You will have still the square of the binomial x minus 1. And you will have here, sorry, again, the square of the binomial x minus 1. And simply write here minus 2. This is your vertex form. So if you're just asking, if you're just asked rather by the vertex form, then you just give this result. But our concern here is determine the standard form using the vertex form. So after this, we need to simplify it further to get the standard form of our quadratic function. And what you need to do is just simply to finalize the process here by squaring this binomial. Take note, you cannot do this power law because the binomial is separated by addition or subtraction, or specifically here subtraction, and the power law will not hold as true. What you could do here is to understand that if you have a square of a binomial, you are to write it in this manner. It is a product of x minus 1 and itself. That's for the square of the binomial. And please do not forget that after that, you still have minus 2 here outside. In short, you just need to solve here this product of two binomials using the FOIL method. The FOIL method. So the FOIL method here, you have x times x. Yeah, that's x squared. X times negative 1, you have minus x. Negative 1 times x, you'll have minus x. And you'll have negative 1 times negative 1, you'll have positive 2. So your quadratic form is x squared minus 2x. Oh, sorry, it's not plus 2. My bad. It's plus 1. Okay, pardon for that. And you have here plus 1. I was actually thinking of the 2 here already. That's why it's being mixed. But this is not the correct form of the square of the binomial x minus 1 or the product of two binomials x minus 1. And simply substitute it here on your form. So you have f of x equals the result, which is x squared minus 2x plus 1. And you still have minus 2. And to finalize your standard form, which is again just one of the possible forms since we just considered a equals 1, equal to x squared minus 2x, and the result of this, which is minus 1. So from your vertex form, this is your standard form, and this is our final result. So see, even just by the given vertex, we can still get the standard form. But first, we need to pass through the correct vertex form in order for us to get that. Let us try to duplicate this process for number 2 here. And first, let's try to determine the vertex. Since again, we are considering per one grid is 1 unit. So you have 1, 2, 3, 4. So it's actually a negative 4. And you'll have 1 here. So 1. The vertex is at negative 4 and 1. We are going to use the same process here. First, substitute such vertex on our vertex form, get its correct vertex form, and proceed further using the FOIL method for the square of the binomial, and finalize to get your standard form. If this is your vertex, don't forget that this negative 4 is your h, and 1 is your k. So your standard form, or rather, your vertex form, again with the notation that a is 1, so you will get the result here equal to still 1, and you have x minus negative 4. Again, the difference with the h value in numbers 1 and number 2 is that in number 1, the h value is positive. That's why it's x minus 1 as for the vertex form is concerned. But here in number 2, h is already negative. So please do not forget that the vertex form follows x minus h plus k. Again, the square of x minus h plus k. But since h is already negative, so it will become x minus h, which is negative 4. You take the square of that, and then plus your k, which is 1. In short, here you will see double negative, and your final vertex form should be given with this form. It will become x plus 4, the square of that binomial plus 1. This is your correct vertex form. Again, this is your correct vertex form. But we are not just asked about the vertex form, but rather we are asked to use this vertex form in order for us to get the standard form. Again, one of the possible standard form of the quadratic function having the vertex negative 4 and 1. So let us go further. In this squaring of binomial means, we will be using the FOIL method, because it will be written like this. F of x is the result when we multiply x plus 4 by itself as the square is being referred to, and then plus 1, the additional term outside. So for the FOIL method, you will have x squared. X times 4 is positive 4x, and another positive 4x, and you have plus 16. Again, not use that one yet. We are just solving the result of the product of two binomials. You have x squared plus 8x plus 16. This is the result of these two binomials here. In short, our next part here is when we return to that value, x squared plus 8x plus 16 plus 1, that should not be forgotten. In short, our final standard form is given to us by x squared plus 8x plus 17. This is our standard form, sample, again, representative standard form of a quadratic function. These are made possible even if you are only given with one special point, the vertex. These are all made possible by the vertex form and then later on standard form. This ends this practice exercise for those two items. But I actually copied the previous two examples in the previous video. This is the result in the previous video where we used intercepts of this table of values, and we also used the intercept of this graph. But we already had their standard forms here. But let us try to see if we will have the same result if we are going to use the vertex form. For this table of values, using the pattern that you can see, your vertex is actually this here. Let us see if we're going to use the vertex form and whether we will end up with the same result. Similarly here, we will use this vertex later and determine if we have the same result at the bottom. Let's start with number 3. Again, the vertex is at 3, negative 4. So the vertex is at 3 and negative 4. So working towards that, your vertex form is actually x minus h, that's 3, the square of that binomial, plus you'll have negative 4 here. The final form of your vertex form in the meantime is the square of x minus 3 minus 4. Okay? And we will use the FOIL method to solve for this. We will have the FOIL method here, or let's try to write it in this manner first. You will have f of x is equal to the product of multiplying x minus 3 by itself. Okay, just like that. Minus 4 outside. We will use the FOIL method here. So the FOIL, x times x is x squared. X times negative 3 rather, times negative 3 is negative 3x. Negative 3 times x, another negative 3x. And you have plus 9. Your quadratic expression after this binomial, two binomials are after they are multiplied, you'll have x squared minus 6x plus 9. Returning here, to get our standard form from this vertex form, the color blue one, you will have x squared, minus 6x plus 9 minus 4, which will end up to this standard form, x squared minus 6x plus, it's no longer 9. 9 minus 4 is plus 5. So this is now the standard form of quadratic equation using the vertex and this equivalent vertex form. If we are going to examine the previous answer, look into them. You have this like that. This was using the given intercepts here. In the previous video, you might want to check on that. And this is by using the vertex, which is also given by the graph. You end up with the same representative quadratic function. But then again, I'm mentioning this might be just one of the possible because it will depend on possible multiples later. See, our two processes end up with the same answer. Let's try to see if that is the same case with the question number 4 in the previous video using intercepts here and coming up with this result. Here, instead of intercepts, let's use the vertex. And the vertex is at somewhere here for x 1, 2, 3, 4, 5, 6, 7. So the vertex is at 7. And then 1, 2, 3, 4. You will have negative 4. So this is your vertex. Let's see if using vertex form, if we will end up with the same result here. Let's check. So this is our h, that's our k. So the vertex form, is given to us by the f of x. Again, a is equal to 1. X minus 7, the square of this binomial. Again, you will have here plus negative 4. And your final vertex form is f of x, f of x equals, you will have the same binomial, x minus 7 square, or the square of it, minus 4. This is your vertex form. If we're going to continue in getting its standard form, because that's our goal, this square of the binomial means we are just multiplying x minus 7 by itself, and then we copy minus 4 here later. Let's use again the FOIL method for this expression. You have the FOIL method here. That's FOIL. Sorry. Okay, that's like that. So you have x times x is x squared. X times negative 7 is minus 7x. Negative 7 times x is also minus 7x. And then negative 7 times negative 7 is plus 49. In short, the quadratic form for the square of the binomial here is x squared minus 14x plus 49. Let's substitute this here and continue with this expression. F of x, in getting the standard form, x squared minus 14x plus 49 minus 4, which is the remaining term here, and is therefore the standard form of this graph. This graph, using the vertex, is given as x squared minus 14x plus 45. This is the standard form using this process. And let's see if we have the same result using the intercepts in the previous video. As you can see, they are just the same. So using the intercepts and the vertices, you will end up with the same result. It's just that for these additional items, which are also part of the previous video, intercepts are clearly given. And the point to that is you could choose which method you would like, because they will still end up with the same result here and here as well. But for the original items of this video, the intercepts are not clearly stated for number 1, and number 2, there's no x-intercept, and hence we have no option than to use the vertex form in getting the equivalent standard form of quadratic function. Thank you very much for watching. God bless and goodbye.